Welcome. Here we are, Chapter 9, and now we begin the last major topic of the course, division. We'll look at some of the basic things in division like we've done in the other operations. We'll look at models, properties, and algorithms, and we'll also look at division with fractions. So today, we look at the models. What are the different ways that we think about division? And even before models, I want to take some time thinking about the definition of division. When I write a divided by b equals c, what that means is that a equals b times c. So this multiplication problem and this division problem are exactly the same. If one is true, then the other. Let's think about it in terms of actual numbers. 18 divided by 3 equals 6. That means that 18 equals 6 times 3. So how about this problem? Since 28 divided by 4 is 7, what does that mean in terms of multiplication? Do you know? It means 28 equals 4 times 7. How about going the other way around? Here's my multiplication. Since 15 equals 5 times 3, we know what? 15 divided by 5 equals 3. Now, also, we could say that 15 divided by 3 equals 5. So either way is fine. This definition gives us a good reason why we can't divide by 0. This is a question a lot of people often have. You sort of hear it as a rule. You can't divide by 0. But why not? So here is the actual answer. Why can't you divide by 0? Let's suppose that 8 divided by 0 was actually some number. 8 divided by 0 equals something. Well, let's use our definition. If 8 divided by 0 equals a number, well, then that means, so if and only if, is our biconditional from the first week of class, if 8 divided by 0 equals a number, that means exactly that 8 equals 0 times that number. But that's impossible, right? You can't have 8 being 0 times anything. So there's no solution. Can't happen. And so this is why we say 8 divided by 0 is undefined. I can't define a number there and have it make any sense at all. Okay, now let's turn our attention to the two models of division. Only two models, right? That's kind of nice. Not that many to worry about. The first model is how many in each group. So let's say my division problem is 10 divided by 2 equals 5. I might think of it this way. I have 10 objects, and I'm grouping them into two groups. So if I take 10 things and put them into two groups, how many objects are in each group? And that's where the model gets its name. How many in each group? This is also called the partitioning model. I have 10 objects and I partition them into two groups. How many objects are in each partition? So here's an example problem. 10 bones are given to 2 dogs. How many bones does each dog get? I sort of mentally have this image of 10 bones being divided into 2 piles, and each dog gets 5 bones. 10 divided by 2 equals 5. How about the next model? How many groups? We might think of 10 divided by 2 equals 5 in this way. I have 10 objects, and I group them into groups of 2. And if I do that, how many groups will I get? A lot of times I use the word into. How many times does 2 go into 10? Or if I write as a fraction, 10 over 2, a lot of times I think 2 into 10. How many times does 2 go into 10 for my answer there? This is also called the measurement model. We measure out 10 objects by 2. I might think of it like if I wrote 10 dots, 7, 8, 9, 10, and I just start measuring by 2's. Measure by 2, measure by 2, measure by 2, by 2, by 2. How many lengths of 2 will it take? It takes me 5 of those lengths. So here's an example problem. 10 travelers take taxis from the airport to the hotel. Each taxi holds 2 people. How many taxis are needed? So, of course, it's still the same division problem as before. 10 divided by 2 equals 5. But conceptually, it's a little different, right? I have 10 travelers. Each is being paired together in a taxi. So 10 divided by 2 equals 5. How many times does 2 go into 10? All right, how about a few practice problems? Here are 4 examples. What is the division problem and what is the model? Pause the video now. Look at these 2 problems, think about them carefully, and when you're ready to check the answer, then begin again. All right, I assume you've tried, so welcome back. Let's take a look at these 2. Number 1, Gloria has 35 candies to distribute equally among 5 children. How many candies does each child get? So the division problem is 35 divided by 5. The answer is 7 candies. And this is a how many in each group problem. I think of the groups as the kids, and so each kid gets 7 candies. 7 candies per group. All right, how about number 2? Bill has a muffin recipe that calls for 2 cups of flour. How many batches of muffins can he make if he has 8 cups of flour? So the division problem is 8 divided by 2. So the answer is 4 batches. And I think of this as an into problem. 2 into 8. It takes 2 cups to make a batch. I have available 8 altogether. So 2 goes into 8 4 times. So this is a how many groups problem. All right, 2 more problems, and I think these are a little more challenging. So pause the video again, and when you're ready to check the answers, start it up. All right, welcome back. You've tried, right? Okay, let's take a look. Problem number 3. It takes my tractor 2 gallons of gas to drive 3 miles. How many miles per gallon does my tractor get? So the division is almost given right in the question itself. Miles per gallon. When you see the word per, that means division. Miles divided by gallons. So I'm thinking miles divided by gallons. Miles per gallon. And I have 3 miles, so 3. And I have 2 gallons. So 3 miles per 2 gallons. 3 divided by 2. So 3 divided by 2 is 1.5. The tricky part in this problem is the model. What model is this really? And I'll tell you, the model is how many in each group. It might be a little hard to see, but maybe here's one way to think about it. Miles per gallon. So gallons is the group. And so I've got 2 gallons. So maybe I'm thinking, all right, 2 gallons, a gallon. And I have to fit 3 miles into this 2 gallons. So maybe that represents a mile, and that represents a mile, and that represents a mile. So mile, mile, mile. How many miles are there in each gallon? Well, one of these miles have to split down the middle, so that gives me 1.5 miles in each gallon. I know, it's a little weird. I'm trying to stretch the model a little bit, but it would be a how many in each group model. Problem number 4. The bag of fertilizer covers 120 feet. How many bags will I need to cover 80 feet? For me, actually the very first thing I think about in this problem is the model. And I think about this as a measuring model. And measuring was our how many groups. And actually, recognizing this as the how many groups or measurement model helps me figure out the division. Because a bag of fertilizer covers 120 feet. These are sort of equivalent. One bag is the same as 120 feet. So how many bags will I need to cover 80? I'm really asking myself, how many bags go into 80 feet? How many times does 120 go into 80? And so I can reduce that fraction. 8 over 12 divided by 4 equals 2 over 3. So 2/3 of a bag. Hopefully that makes sense. How many groups? I'm almost thinking about this one as more of the measuring model, using a bag to measure out how many square feet we can cover. Okay, so hopefully this makes sense. Give the homework problems a try. There are some good homework problems in this worksheet, so don't neglect those. Do your very best on those. And for the worksheet problems, of course, as always, check your answers, and don't be afraid to contact me if you have questions. Okay, go to it, and good luck.